Good morning students. So 12th standard physics. So in this class we are going to discuss about self-inductance of long solenoid. So consider a solenoid of length L, area of cross section A. So many number of turns in the solenoid. So current I flowing through the solenoid. So due to the current flow there is a magnetic field around the solenoid. So the magnetic field at the center of the solenoid B equal to mu 0 Ni. So N is a turn density, that is number of turns per unit length. Then so what is the magnetic flux for each turn of the solenoid? So what is my magnetic flux? So number of magnetic field lines passes through the given area, that is kept normal to the magnetic field. So the direction of magnetic field in this direction, then the n cap, that is normal vector, also in the same direction. So theta equal to 0. So pi is equal to b dot A. So that A dot B equal to AB cos theta. So integral dA equal to A. So cos 0 1. So we will get magnetic flux BA. Then substitute B equal to mu 0 Ni. So magnetic flux for a single turn of a solenoid, mu 0 equal to, that is by B equal to mu 0 Nia. Then so for total number of turns, so for entire solenoid, so what is the magnetic flux? That is flux linkage. So that is NL times mu 0 Nia. So n into n squared. So finally you will get mu 0 n squared AL times I. So we know the flux linkage is directly proportional to the current flowing through the solenoid. So L is the self-inductance. So just equate 1 and 2, you will get self-inductance of the solenoid. So L is equal to mu 0 n squared AL. So that self-inductance mainly depends upon the geometry of the solenoid. Here area of cross section and length of the solenoid as well as number of turns per unit length. If it is air is present or vacuum is present inside the solenoid, the formula is correct. But if it is a soft iron core present, that is some medium is present, that is due to have some dielectric constant. So mu is mu 0 mu r. So mu r is a relative permeability of that medium. So regarding this we are going to see one problem. So consider a solenoid of 500 turns, then soft iron core have a dielectric constant 800. So radius of the solenoid is 3 cm, the length of the solenoid is 40 cm. So you need to make it in meter. So it's 40 cm is 0.4 meter. So 3 cm 3 into 10 power minus 2 meter. So there is a change in current from 0 to 3 ampere for a time 0.4 seconds. So we are going to find what is the self-inductance of that solenoid having 500 turns. So just substitute the values. So L equal to mu 0 mu r. So here n squared. So instead of n square you need to use capital N squared by small n squared. So area A is equal to pi r squared. So pi r squared is a circle. So 3.14 into radius of the solenoid, that is 3 into 10 power minus 2. We will get finally L equal to 1.77 Henry. Then so the self-inductance we have find. Then what is the induced EMF due to the change in current for a time t? So induced EMF equal to minus L times dA by dt. So we know the value. So 1.77 Henry for the self-inductance having number of turns 500. So it's change in current 0 to 3 ampere. So dA is equal to 3 minus 0 3. Then substitute the values, will get 13.275 volt in negative. So the induced EMF is always in opposite direction. So represent that the negative symbol. So that current I flow in this direction, the induced EMF current flow in opposite direction. So in this class we have discussed so self-inductance of the long solenoid. So regarding one problem we have to do. So if you are studying a theory, just do one problem related to the theory, you can understand more. So okay students,